Hi, suppose you are a four-dimensional being and you want to bake an apple pie. So you want to know the volume of apples you need. So you need a formula for calculating the volume of a four-dimensional apple when you know its radius. So we're going to do that. First, we're going to start out with two dimensions. A circle, the surface area of a circle is also called the circumference, and it's 2 pi r, where pi is 3.14159. The volume of a circle is also called area of the circle, is 4 pi r squared. For three dimensions, the surface area of a three-dimensional sphere is 4 pi r squared, and the volume of a four-dimensional sphere is 4 over 3 pi r to the third. If you know the volume of a sphere, you can always get its surface area by taking the derivative with respect to r. So for two dimensions, pi r squared, taking its derivative with respect to r, we get 2 pi r. And for three dimensions, you take its derivative of 4 over 3 pi r to the third, and you get 4 pi r squared for the surface area. What's the surface area and volume of a four-dimensional sphere? Or an n-dimensional sphere? If we find the surface area, we can then integrate and get its volume. If we find the volume, we can then take the derivative with respect to r and obtain its surface area. For a four-dimensional sphere, when I was in high school, I decided to find the formula for the volume and surface area. Since they never taught me that, they only taught me the 2 and 3 dimensions. So I found it using 3 different methods. One method I integrated with kind of a regular sphere shell method. Regular shell method, but for 4 dimensions, I call it sphere shell method. And 2 other methods. The 2D disk shell method. This one is the most interesting, and the calculations come out the easiest. This was very fun to visualize, because even though the calculation is very easy, visualizing is a difficult part, and I spent weeks thinking about this. And the third way is finding the surface area, and then to get the volume, you'll just integrate with respect to r. So, method 2, since this one is the interesting one. So, for a four-dimensional sphere, when you cut a four-dimensional apple, you make a cut with a knife somewhere other than straight in the middle. You get a cut that's a volume. So, we want to to integrate something so that we get the whole volume. So this is a difficult part. You have to think of a circle with pi r squared area rotated around the four-dimensional sphere where the circumference is 2 pi r. So there's really no easy to explain this, but let's say you make an analogy where in 2 dimensions you can have a rectangle, and in 3 dimensions you can take that rectangle and rotate it and patch it up opposite ends and make a cylinder. So this is the same way, except this time you have a solid cylinder with a radius of height as shown in the picture. Y is equal radical r squared minus x squared, and length 2 pi r, and the ends of the solid cylinder meet, kind of like if the universe was just an analogy, but the universe was finite and you had a cylinder and the ends, you could meet the ends if it was going around the universe. Not the best analogy, but the ends meet of the cylinder. So with this method, we have pi r squared, where r of the disk is radical r squared minus x squared. R in this radical r squared minus x squared is the radius of the four-dimensional sphere, and x is the distance from the center of the four-dimensional sphere to the middle of the disk, and then multiply that by 2 pi x. So we multiply that and we get 2 pi squared times xr squared minus x to the third. We want the volume of the above equation. And we want to find the volume. So we need a small dx, and then we integrate from x is equal to 0 to x is equal to r. So at x is equal to 0, the disk of the cylinder we have with length 2 pi r x specifically is the biggest at x is equal to 0, and then it goes to 0 at x is equal to r. So we integrate and we get pi squared r to the fourth over 2. So that's the volume of a four-dimensional sphere. This is an easy mathematical calculation, but difficult to conceptualize visually method 2. So this is the sphere shell method now. So we can calculate the volume using this method. This one's easier to visualize, hopefully, sort of. At least not as difficult as the other one. So with this method, it's kind of like the shell method for 3 dimensions. We have like a cylinder, and in our case, the circle that makes up the cylinder is not a circle, but it's 4 pi r squared. It's the surface area of a 3-dimensional sphere instead of a circle, because we're integrating for a 4-dimensional sphere. I wish I could explain it better, but this one's actually much easier, so it doesn't require much thinking. But the calculation's a little more difficult. You have to integrate sine and you get the same thing. Pi squared r squared over 2. Pi squared r to the fourth over 2. Sorry. That's the end of method 1. Okay, so there's another method. This one's for 2 dimensions, finding the surface area of a 3-dimensional sphere. And kind of, this is easy because it's just 3 dimensions. But it's for analogy to finding the surface area of a 4-dimensional sphere. And we get 2 pi squared r to the third, which is the answer. Oh, this is visible. So there's actually another method that I found a few years after I did my calculations, after I bought this book. Gravitational, Mr. Thorne Wheeler, 1973. So, instead of an apple, they say the sphere is a 4-dimensional universe. So, I don't know if you can see that. Page 723 in Mr. Thorne Wheeler. And they get the same answer, which is the first check I got. I waited a few years, but I was sure of the answer anyways. I don't know if you can see this. So they integrate 4 pi a squared sine squared x Well, chi times a d chi is equal to 2 pi squared a to the third. And I checked it, the calculation, and it's good. So, we got 2 dimensions, 3 dimensions, 4 dimensions. What is the general formula for n number of dimensions? So, I think I did this later. Yeah. Once you have the first 4 dimensions, you can just easily generalize. I haven't looked for it on the web, so you can look for it on the web. Maybe you can post it in the comment. Thank you very much.